Okay, let me try to show you how we should go about in doing an inclining test question. What I have put here is the last question in your exercise, question number 7. So one thing to remember is that when we do the inclining test, the main purpose or the goal of doing the inclining test is to find the vessel's kg at the light ship condition. However, although the goal is that, from the inclining test by itself, what we can find out is the GM at the inclining time. At the time of the test, we are calculating the GM of the ship. And from that GM, we will be able to find out the light ship kg of the ship. So when you get your question, one thing to do is to know that all the data shown here, all the data that is shown here are relevant to the vessel which is inclined. That means at the time of inclination. So it's very important that we are referring to at the time of inclination. Now I'll be over and over repeating this word, at the time of inclination. So at the time of inclination, this is the set of information that we have for the ship. But what we want is the light ship kg. So the question is, if at the time of inclination, if the ship is in light ship condition. If it is not, we have to adjust the data that we have so that we will have light ship conditions. So at the time of inclination, the vessel's displacement is 34,000 here. At the time of inclination, the Km is 11.8. And at the time of inclination, there are stores, some ballast water, fresh water, and things. So you should identify here, at the time of inclination, what is it that is not part of the light ship, and what is a part of light ship that still has not come on board. So we'll go to the first one. Stores and sundries is not a part of light ship, so I will just mark it. At the time of inclination, there had been number 1 double bottom tank with 655 tons of ballast, not a part of light ship. Fuel oil tank, 325 tons, not a part. Water in the boiler to working level is a part of light ship. So leave it as it is. Fresh water by itself, 185 tons, not a part of light ship. Inclining weights is not a part of light ship. The ship's radar mast is yet to come. So this is part of light ship. The inclining weights which we have already taken into account here. So that's okay. So first we have found out what is not going to be part of the light ship. Now at the time of inclination, what I said is that what the inclining test will give us a GM. Whether this is GM solid or fluid will depend on the condition of the tanks at the time of inclination. So we can see that there has been a slack tank here causing free surface moment, a slack tank here causing free surface moment, a slack tank here, and a slack tank here, which means that by the inclining test, what we would get is a GM fluid. So if you remember the diagram when we did our inclining test, so that was the ship that has been inclined. That's the center line of the ship, the keel, center of gravity, but that's fluid center of gravity because we have liquids that are moving during the time of inclination. So center of gravity moves parallel to the movement of the inclining weights, G1. So force of gravity acts there. And force of buoyancy and force of gravity will be on the same line. The vessel will stop heeling, and that's called the metacenter. The plumb line, or the plumb that was hung, will also take a swing now to the same angle. So if you remember in this diagram, we looked at a small triangle, then we looked at this big triangle. And then we derived the formula. Say tan theta, looking at the small triangle, is equal to GG1 divided by GM fluid. And from the larger triangle, tan theta is equal to deflection divided by line length, the effective length of the line. That's that length. So since tan theta is equal to this and tan theta is equal to this, we can say, therefore, GG1 divided by GM fluid is equal to deflection divided by length of line. So we cross multiply this, and we can say GG1 times line length equals deflection times GM fluid. Therefore, GM fluid at the time of inclination is equal to G1 times length, or the shorten that word length, divided by deflection. Now we start substituting the values that we know. Length is known. The line length is line length is 10.2 meters. The deflection is known, 1.21 meters. So GG1, we work it out separately. small d is how far were the inclining weights moved. 7.45 meters horizontally. W is the weight that was moved. That's 72 tons divided by, at the time of inclination, the displacement was 34,000. That's equal to 0.016. Now we'll substitute this value here. We could say instead of GT1, 0.016 times 10.2 divided by 1.21 equals GM fluid. But we know that Km at the time of inclination is given in the calculation, in the sum, it is given as 11.8 meters. Therefore, kg fluid will be equal to Km minus Gm fluid. That's 11.8 minus 0.133 equals 11.667 meters. So this is the fluid kg at the time of inclining. The free surface correction at the time of inclination will be equal to free surface moment divided by displacement. What we want to do is to find out the solid kg by applying the free surface correction. So, free surface moment. Now let's see what are the free surface moments at the time of inclination. At the time of inclination, we have this free surface moment, that free surface moment. Water in the boiler is causing a free surface moment of 109, but since water in the boiler to the working level is a part of light ship, we ignore the free surface moment. You consider that that's a solid, because that free surface will be there on the ship lifetime. So those are the only free surface moments. Oh, sorry, there is another one. Freshwater tank as free surface. So our total free surface moments is equal to 2,300 plus 2,100 plus 1,225 divided by, At the time of inclination, the displacement was 34,000. So we get a free surface correction of 0.165. Therefore, kg solid will be equal to kg fluid minus free surface correction, and you will get 11.667 minus 0.165 equals to 11.502 meters. So this is the solid kg of the ship at the time of inclination. So this is the first stage of the calculation, stage 1. One of the calculation is to get the solid kg at the time of inclination. Solid kg at time of inclination. So we can now say that we have a ship of displacement 34,000, solid kg 11.502, km 11.8. So this is at the time of inclination, but we must now adjust our weights so that we convert this to the light ship definition. How would you do that? That's our stage 2. So stage 2 in the calculation is to bring the vessel light ship status. Remarks: weight, vertical moment, sorry, it should be kg and vertical moment. So remarks: the inclined vessel, what was the weight? 34,000. kg 11.502. Vertical moments, which means you multiply we have some stores which has to be taken out because it's not part of your light ship. So what you do is, when you are taking it out, you keep striking this off. You have now taken that into account. Next one is bunkers. Minus 325, kg 3.21. Therefore, minus vertical moments. go back. Bunkers. Taken out. So when you keep striking it off, you will also keep a check whether you have missed any. Then we have ballast. It's not a part of flight ship, so we must take that out. Fresh water is not a part of light ship. Take that out. Inclining weights, the weights that you use for inclining, it's not a part of light ship. Take that out. Water in the boiler. Is a part of light ship. Is a part of light ship. So we have done that. We have taken that out. Water in the boiler is a part of light ship, and there is 36 tons there. But this 36 tons is already in the 34,000 weight. Therefore, we don't do anything with it. So we leave that. Then we have a crane, which is forming part of the light ship, but it is still outside. Let's assume that we have to bring that on board. 50 tons. And where are we going to put it? In a position kg 9 meters. Therefore, it's a plus. So we started with an inclining vessel that was inclined vessel. Then we adjusted our weights plus or minus. So we will end up with the light ship vessel. Therefore, light ship kg equals vertical moments divided by displacement equals 11.820 meters. So in other words, at the time of inclination, we found that this is the kg at the time of inclination, but the light ship kg is this. After all adjustments. Hope you understand this now.